Hello and welcome to a video on isosceles triangles. So we're going to delve into the details of isosceles triangles in this video and then look at several examples of how to apply that to find missing sides and missing angles. Alright, so first of all, the parts of an isosceles triangle. So the legs are the two congruent sides. So in this triangle that you're looking at here, the two sides that are marked congruent, those are called the legs. And in this case, that's just simply segment AB, which is congruent to segment BC. Okay, the angle where the legs intersect, so they intersect up here at B, so that's just angle B, and that's just the vertex angle. And then the base, the side opposite the vertex angle is called the base. So if this is the vertex angle, this is the base. It's the other side. So it's the side that's not the legs. In this case, the base is AC, segment AC. And the angles that are attached to the base, a part of the base, angle 2 and angle 3, you could call them angle A and angle C. They're base angles. So, and they're equal. So the angle A is congruent to angle C. And we could also say angle 1 is congruent to angle 2. Just remember many ways to name angles, and that's just two of them. We could go even farther and say angle BAC, that's this angle also, is congruent to angle BCA, but we're not going to write that one. Alright, so the isosceles triangle theorem says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if we look at the triangle above, we can see that these two sides are congruent, and I like to draw these little arrows. So if these sides are congruent, and I say the side across from, the angle across from that side and the angle across from that side are congruent. So what this statement is saying is if BC, or AB, sorry, AB is congruent to BC, which in this case they are, it follows, or I'm just going to use the word if then, I'm not going to use the arrow. So it follows, which is then angle A is congruent to angle C. And the converse, now all the converse does, oh, this is not a the, this is a then. What a converse does, the word converse means it takes an if-then statement and it switches the hypothesis and the conclusion. The hypothesis is just the stuff next to the word if, and the conclusion is just the stuff next to the word then. So the converse is saying if two sides of a triangle, if two angles of a triangle are congruent, then the sides opposite of them are congruent. So in this case, it would be saying something like this. If angle A is congruent to angle C, then the side across from A, which is, so the arrows go both ways, in other words, the side across from A, which is BC, segment BC, is congruent to the side across from C, which is AB. Okay? Alright, let's look at some examples with numbers. So we're looking at a triangle, and we can see this triangle is not turned on its side, it's just the base is on the bottom, the two congruent sides. So if these two sides are congruent, then these two angles are also congruent, so this is a 68. So the first thing, very easy, is that angle J is 68. 68 degrees. And we know that angle K is still a third angle of a triangle, so we know that we can take the first two angles, add them up. So 68 and 68 adds up to 136. Subtract that from 180, and we get the third angle, which in this case is the vertex angle, angle K. And this one looks like it's 44 degrees. Okay, so the three angles of the triangle, of course, are still going to have to add up to 360 to 180. Okay, a circle is 360, a triangle is 180. A rectangle is also 360. All right, but not a triangle. Here we're given a base angle, we're given a vertex angle, and we're looking for the base angles. And all we know about them is that whatever one of them is, the other is the same thing. So what we could do, one thing we could do is we could just subtract 106 from 180 and then divide by 2, but I'm going to do this by setting up an algebraic equation, just like we did with the triangle sum. So I know that x plus 106 Those are the three angles of a triangle. Adds up to 180. So 2x plus 106 is 180, which means 2x is 180 minus 106, or 74, and x is half of 74, which is 37. All right, so angle C and E are both 37 degrees. All right, let's move on to the next one. So here we're given two angles, and now we're looking for sides and angles. Notice that the question is asking you for a mix of things. So what we know here is, first of all, we can find the three angles of a triangle the same way that we did in example 1. Once we know the two base angles are the same, we just add them up and subtract from 180. So we can get angle Y by saying 77 plus 77, which is 154, and then 180 minus 154, which is 26. So that vertex angle up there, angle Y, 26 degrees. All right, now what about the sides? Well, now is when we're going to use this rule, these arrows here. So if we know the angles are congruent, then we know that the sides across from them have to be the same also. So if this one is 12 centimeters, so is this one, 12 centimeters. So that's YZ. Okay. Let's go on to number 4. So now let's throw in a little algebra here. So let's look at, we're given the base angles, and we're given that these two sides are congruent, so it's an isosceles triangle, which means that the two angles across from them must be congruent. So there's our equation. 5x plus 9 equals 8x minus 30. And I'm just going to solve that. And there it is, x equals 13. All right, let's not do 5 because it's pretty much the same. I'm going to leave that for your own practice. Let's do number 6. So this time we're given the angles, that they're equal, and so we know that the sides across from them are equal. Notice on this example, it's the sides that point to the angles that must be equal, and here it's the angles that point to the sides that must be equal. So the arrows go both ways, and that's why I have up here the arrows going both directions. Congruent sides means congruent angles, and congruent angles means congruent sides. So in this case, it's the sides that are equal. So we just set these two equal. So 15x plus 7 equals 23x minus 17. Let's solve that. Okay, so x equals 3. And number 7 is very similar to number 6, so I'm going to leave that one for you to practice. I'll write the answers to those and tell you before the video is over. All right, number 8. Let's look at number 8. So we have a triangle. Now this time we don't see a triangle, so we have to draw one. So we're just going to, the only difference between this problem and the others is we have to draw a triangle RST. Now what's important is that when we draw an isosceles triangle, it does matter how we draw it, because we have to make sure that RT and ST are the equal sides and not the base. So I'm going to draw the triangle to make it look like it's an isosceles triangle, and the ones that I want to be the same are RT and ST. Well, they both have T, so I'm going to put T up here, R here, and S here, and that works to give me RT equals ST. All right, so it's important that you do see that. So the point that's the same in both of these, that has to be the vertex. All right, now let's see if we can label this. So angle R is 9x plus 2. So I'm just going to put like a little arrow in here. That angle is 9x plus 2. Angle S is 13x minus 8. So put a little arrow in there, and that's 13x minus 8. Now, angle T, I'm also given angle T, and that's 17x plus 1. Right up there, 17x plus 1. Wait a minute, it didn't even matter as far as the angles that this was a isosceles triangle, because we're going to use the fact, well, we can use either fact here. We can use the fact that these three angles add up to 180. That would be one way to get x. Or we can use the fact that these base angles have to be equal. That seems like the shorter equation, so let's choose that one. So 9x plus 2 equals 13x minus 8. All right, let's solve that. Okay, well, first of all, I had a little mistake that I forgot to make that 18. I had that as 8. So if you're not getting a nice whole number, just kind of catch that mistake there. I had an 8 there before I had you pause the video. All right, so now that we've got x equals 5, we can pretty much find all of these by just plugging in the 5. So we can say 13 times 5 minus 8, 17 times 5 plus 1, and 9 times 5 plus 2. Well, this one I know. I know 9 times 5 is 45, so that's 47. Hopefully this will also be 47. This is 65. Oh, this is an 18. That's fine. That's part of the mistake that I had before. So this is minus 18. So this is 65 minus 18, which is also 47. And then the top one here would be 17 times 5 plus 1, which is, let's see, 50, 86. And there we have them. So just fill them in over here. So we have 86 degrees for the one we just found. S and R are both 47 degrees. And you can check to make sure those add up to 180, but they do. Okay, let's look at number 9. Let's draw a triangle. Angle D and E are the congruent ones. It's a little bit easier when you're given the angles than in number 8 when we're given the sides. So we know that we are going to make a triangle that's isosceles, and these are going to be the equal ones. That's not so hard to see. All right, and then that means that the other angle, which in this case is F, must be the vertex angle. Let's label our DE, x plus 4. Let's label our EF. And these are, by the way, these are congruent. Let me put those as congruent. Let's label EF as 4x minus 8. Let's use the fact that the sides across from those congruent angles are congruent. So we've got our equation. By the way, did I label this wrong? DE is down here. Whoops. X plus 4. EF. This is DF, so this is 7x minus 35. Okay, now we're ready to set up our equation. Because it's isosceles, the base angles are equal, the legs therefore are equal. Our equation 7x minus 35 equals 4x minus 8. Go ahead, pause the video and try to solve that. Okay, got x equals 9. We can see here that DE, so here x equals 9, let's put that one in there. DE is 13. And then this is 63 minus 35. This one is 36 minus 8. 36 minus 8 is 28. They're both 28. Now, this time they don't have to add up to 180 because they're not angles. Only angles have to add up to 180. The sides have no special number like that. All right, let's do one more, and then we'll end this video. So let's set up number 10. I'm going to draw it and show you what it looks like. Okay, now notice that I made the two sides that are congruent both have W. So again, I made that the vertex angle just like I did in number 8. I made T the vertex because it's in both of those. And I set them equal, so I marked them as equal. Now I'm going to label them. Okay, I labeled them according to what was given. Now I'm going to do the same thing. The base angles are equal, so I'm going to set them equal. 5x minus 12 equals 7x minus 48, and then solve that. Okay, so we got x equals 18. Now I'm going to plug 18 into each of these to get the 3 angles. Okay, so I got the base angles being equal like I expected. So x and y are both 78 degrees. And the vertex angle is 24 degrees. And if you add them up, they should add up to 180, and they do. Okay, here's the answers for the 2 that we skipped. So you can work those out on your own. And I hope you found this video helpful.